Wow. No echo. Amazing. So I cannot even make jokes about your first presentation because mine started even more worse than yours. Sorry for that. So, greetings. Yeah, it's really my first time I'm talking here and trying to moderate. After David, here we have Randall and Amir. Yeah, this time it's me. And when was the last meetup? So it was now, I write it down, in January 2023. So now, I think even in January we had Gamma 2022.5 or what? So, okay, but yeah. Time is passing fast, even for the namings for Gamma. Now we have Gamma 5.2 without dates. So, hello, everyone at YouTube and Zoom, and hi, still also here, and on Element. So we are reading the chats on all the three channels. Ask us questions, pass also by. If someone sees us now live, we have free drinks here. And I also think there's enough space for more people. So people who are still here from the parade can also be here after our making and then go to the next club. So what is going on today? We have a lot of speakers I see here. So then we start with a little short introduction of the people who are already on a kind of list, and they're also for everyone open if there is time slots. Just say who you are, what you want to talk about, and then we jump to the next. So we start here when I see the camera with beside me, Amir wants to be talking today.
Hello, Berlin, and hello, Internet. Thank you very much, Daniel. It's a very nice feeling to not be the moderator, but also I feel a little jealous now because I think you're having a lot of fun being a moderator. But anyway, so my name is Amir, and I'm going to show you some robot-related projects and some, one robot-related project that I'm going to show you and talk about it. And of course, I'm going to show two packages that I have been working on if everything works well.
Amazing. Then let's jump to Chris from Wir machen bunt.
Yeah, hi, I'm Chris from Wir machen bunt. I'm going to talk about the Utopian Garden immersive show, and I always loved using Gamma.
Great. And then Kevin Blackistone is also on the list.
Yeah, I'm going to be discussing a half-hour dance performance I was recently doing the visuals for in Ars Electronica Deep Space.
Great. Christian, you are often on the list, or?
Yeah, I will give a little course on the latest stuff on fuse development.
Cool. Amazing. Then, I see here Michael Berg from SchnellerBunderBilder, but I'm also finding it.
Hi, I'm Michael of SchnellerBunderBilder, and I'm going to present two projects tonight, which have not been released yet, and one small contribution that is used in one of them.
Okay, so then I talk now for Christoph, because Christoph Kirchmeier is still on a workshop for Note Institute, and will join us when he's finishing the workshop, and I think talk also a little bit about what he is doing in workshops. And here we have them all from this guy that he wants to do something.
Yeah, hi, I'm Elias. What are the 5-minute little thing developments on VVVV Gamma itself? And Sebastian, I believe, also wants to do a little 5-minute slot. So maybe at the very end. Okay. Or
as you like, then we put you on the end. And if there okay, then let's do it. Let's start the thing. I go for another beer and give my technical director the fun.
it's Amir.
Amir's stage. You have stage now.
Cheers, Dan. Cheers. Okay, I'm gonna share my screen. Do I need yeah, okay, I think Maxim, you should allow me to do that.
That wasn't by default. Always the Zoom. Try again.
Oh. Yes, perfect. Good. So, do you see what I see? I hope you do. Do you see my screen?
Yes, we do.
Yes.
Okay, good. So what I'm going to talk about is that how we can possibly in currently or hopefully in near future, everybody else, simulating, visualizing, and controlling robots in our beloved VVVV Gamma. So I've been working on a utility for the past, I don't know, 3-4 years, I would say. I'm in the stage that my PhD is almost done. And as part of my PhD, which is about human-robot transference, that works on basically human behavior, human-robot interaction, and programming, of course, robots. And of course, we go a bit detailed and deeper, and we talk about behavioral trees, finite state machines, timelines, and whatever makes computers behaving in a way that we think of them more as closer to human and less close to machines. Whatever, that is the theoretical part of it. But of course, for realizing some of the artistic practices, I had to come up with a tool and utility that I could dynamically and playfully control robots, of course, in real time. I'm working on a package. It's currently called Bonraco. I do know that it's not the best name to call a package, but yeah, well, we will see. The idea that I call it Bonraco, as you may have heard or may know from the Japanese theater style, Bonraco is the one that those people who basically move these puppets, they wear entirely black, and then you just basically pretend that you don't see them, but you only see the puppets that they are moving around. And the job of those puppet players is basically to get these joints of these puppets and move them around and be camouflaged to the background. That's why I try to call it Bonraco. So Bonraco has, let's say, 1, 2, 3, and 4 main components to work. And what you see on the stride renderer over there, I call it Bonraco scene. Things are a little rough right now. They're getting together, so bear with me if something doesn't work. Hopefully everything should work. So we have something called construct a robot that basically we need to provide a robot for, and then afterwards we can visualize it. So if I'm able to connect the robot visualization to Bonraco scene, so nothing should happen technically, and I'm going to connect the KR10 R11. I think that should be this one, the white one that you see over here. When I connect it there, you see that it's a stretch robot, and I tell you in a second why that happens. And of course, I have one class called motion handler that it basically takes care of whatever motion you want to apply to the robot. And then I have 2 options, whether axis motion or Cartesian motion. I'm going for the axis motion right now, and you see that the robot jumps up. We have an IO box with 6 axis values because we have 6 joints over there. Let me change the step size. And then that is the axis 1 and axis 2, 3, and so on and so forth. And now if I were to disconnect the axis motion and say I'm going to have the Cartesian motion, so basically instead of having the axis values which produce a forward kinematics for me, now we have basically x, y, z that is equivalent to, let's say, inverse kinematic. So I can basically go back and forth, up and down, and left and right. So that is the bare bone of the whole thing. So I need to say basically the inverse kinematic calculation is backed by the KUKA PRC. KUKA PRC, I think I talked about this before here, and you may know that as well. KUKA PRC is developed by Johannes Braumann, who actually is my supervisor for my PhD. I'm working in his lab, and I'm using his IQ solver here, and of course the knowledge of the parametric controlling and parametric programming robots. So that is basically the base of what we can create a robot, and then we can manipulate this motion. And of course, one thing that it would be interesting is that this class of the motion handler, if I go there inside the motion handler, I might have something called get axis values, and then as you may notice over there, that the basically XYZ position and ABC will become axis values, and then with different communication protocols, depending on what robot we are using, we can send this axis in real time, axis values in real time to the robots, and then you see the robots moving in a way that they should move. Well, did I hear somebody said, what about if you want to control multi-robots? Well, in that sense, I'm going to basically surround the robot visualization in a for each. We need to have a group spectral. And then after that, let's say we have the construct robot over here. Everything actually, let's say I would like to have that motion, axis motion over here as well. Let's move it there. And this guys also should be Control C, Control V. Let's do this smart tiny cones thingy over there. I connect these two things together. And then I'm going to connect the cones, chop, chop. And of course, now we have another robot over there, which we don't want this to be exactly where the base of the previous robot is there. And of course, actually, I would like to use another robot there. So let's go to the robots. There is, we use Agilus. Let's go for Cybertech. Cybertech might be this red one that is in the very, very back, if you see in the camera over there. And then we're going to use a translate over here and translate 3D, chop, chop. And let's say you shoops a little to that direction. And then if I connect the axis motion over there, you see that I have the axis values for the other robot. And of course, we can also get the axis motion. And of course, I can connect perhaps the Cartesian motion instead of the axis motion over there as well. So basically, they are trying to solve the I key for one shared position, although being in different places. So there are a few robots already available. Let me show you one more, and then I move on. I mean, you get the idea. I don't want to waste your time over here now. So let's say Control C, Control V, and I'm going to show you a new category of the robots which KUKA is developing, and they are like super fresh. They were basically showcased very recently, 2 weeks ago in Munich Messe, and this is called LBR Easy. This robot is particularly interesting, and I tell you in a second why. So let's put that one over there. And of course, we can also use the axis motion for this tiny robot over here, or the basically XYZ coordinates. So let's get to this LBR Easy. These are the collaborative robots. Like for example, if you see this Agilus or the other Cybertech over there, if you see it in a production, you will see they are always in a cage. But this one, LBR, and the other basically other robots from the same family, they are collaborative robots, and they come with a hand guiding feature. That means they have this thingy over here called flange commander. You just press these two buttons with your hand, and then you move the robot back and forth with your hand. And then basically we can visualize that in V4, in Gamma as well. And then you just press one button, it saves that coordinates, you go to another position, it saves another position, and so on and so forth. I'm going to show you an actual robot to interact with VVVV, but it's not this robot. Instead, I'm going to show the projects that we did 2-3 weeks ago in Munich. So from the university, we got invited to be, well, basically we applied for this innovation award that KUKA has every year. And then we went to the finals. Well, we did go to the finals, but unfortunately we didn't win. What I'm going to show you is right now, this project, it's basically a collaborative effort between creative robotics, this department I work for, and the fashion and technology. We are looking into future of sustainability, and the project that we have there is that basically we try to repair garment and clothes using electro-spinning technology. And this is basically what is mounted on the robot over there. And to see the visualization in the back, basically what is happening is that this installation has two modes. One of them is the collaborative mode, and the other one is the production mode. In the production mode, basically the robot moves around, and it turns on this electro-spinning that it basically, it's a high voltage polymer that is being sprayed on the garment. It creates something very crazy and very futuristic, similar to a spider web, and it goes into the weave of the fabric. And that is basically the production mode. And of course, in the collaborative mode, you can use this robot to move it around to target those areas of the garment that they need to be repaired. And basically by so, we use the robot as an interface to control the whole installation, but also we use the same robot for the production purposes. And of course, the visualization, everything that you see is happening in real time. In the background, they are all rendered in Stride in Gamma, and then we have some tiny basically interfaces that you can you know what are you doing. So basically we are visualizing the access values, the torque, the distance from this robot and the other robot. One thing that I found very interesting was that basically we are controlling another robot using this robot over here. So we have this multi-robot installation that exactly as you see here, by controlling easy over here, the white plastic looking one, we are controlling the robot in the back that holding the mannequin. So what is happening here, if I also show it to you on the screen over there, you see when the user is pressing a button, there are some red dots appearing on the mannequin there. So basically we are capturing the position from the direction of the robot that is over there. And then we send this coordinate to Grasshopper. Grasshopper calculates basically, it basically has this algorithm that creates this parametric tool path for the robot that they're aligned to the body of the mannequin, and then it sends back those tool path to V4. But it doesn't send only the tool path, it actually sends the robot command back to V4 for each of these two robots that you see on a screen. And then in V4 in Gamma, we get all these commands, we split them, we separate them, we sort them, we create a dictionary, and we put them in a timeline that we know which robot should go first, which should go second, how long should one robot stay and wait for the other one, and so on and so forth. So it makes this orchestration in the middle that it sends in real time, okay, now your turn, now your turn, now your turn. So that was the project. This is Emanuel Golub that you see here, my colleague, together with Johannes and Christiane. We basically did this project there. Unfortunately, we didn't win, but we just went to finals. Polytechnic Milan won the award. Anyways, I promised that I'm going to show you one robot interaction, which is part of the Bonraco package, but it is not this robot there. So you may have heard of, I think I wish that I could change my camera to the, do you see? Yeah,
Yes,
okay, so that is the spot. It's the Boston Dynamics robot that you see on the floor in front of me. And basically we have in the Bonraco package, we have one help patch called example controlling spot. So basically what you want to do is like you connect to the robot. Like the way that it works is that you turn on the robot and then you connect through internet, through Wi-Fi to the robot. And then you press this button, connect, and then you get connected to the robot. I already did that. I don't want to waste your time here. And then basically with all these note sets that you have there, that I just also put them together for this demo. Normally you don't get them like that. You have to put them together yourself. We are going to say, hey, stand up. And there we go. And that guy is over there. And let's say we want this to turn around. We give it an angle and then we set the condition that this guy is basically rotating to look at us. Maybe I should stop sharing my screen and then that you can see my my camera better. Is that, you think that would be better? Anyways, trust me, this robot is moving by V4. Okay, I'm gonna put that one on 0, and then we're gonna change the body height of the robot as well, as you see in here in real time, and then we're gonna change that back and forth a little. We say look down and look up. And yeah, I think here technically should be the end of this presentation. I need to say that it's the Bonraco itself is already equipped by the beautifully contributed recently from Christian, who is also here with the automata. So we have an automata ready for the Bonraco. You just put them together and then you send the robot back and forth. Thank you very much, Christian, for taking care of automata and keep developing it. Also, it comes with the latest version of Kairos. Nathan, if you see us or hear us, well done. Thank you very much. And also, I'm currently working on a node set for behavioral trees that today I did manage to get some early result, like super early result, but positive. So I think soon I'm looking forward to be able to share this with everybody and get some feedback. I think that is from my side. Thank you very much.
Yes, amazing, Amir. I was even thinking about, so when is a robot dancing, and we bring it up at the last the last one, even Boston Dynamics one. Wow! So from Kairos to even you come up with IK solvers. There's a lot of things in there. Also automata. That's amazing. Questions here around or in Zoom?
No questions.
No question. Yeah, it was a lot. It was everything worked. I click, and I also.
I hope it wasn't boring.
Best presentation so far.
Yeah.
Cool. Thank you very much.
A lot of magic. Just one click, and suddenly there's something happens. So I don't even know of asking what is all behind this magic. And congratulations for the finals. So you are now in the finals, and will become, you can be even the winner, or it's
no, it is already decided. We went to the finals, we didn't win, but yeah.
And then who beat this?
I think it was another application, which was, yeah, it was a totally different angle, but yeah, they were very good. They deserved it.
Yeah, very nice. Cool. So really okay, that's question.
Yeah, you mentioned the use of Grasshopper for the project that you brought to mind, and I'm interested in knowing like how you separate the workload between Grasshopper or V4, or if there's like specific use case that you would rather use one software or the other.
Yeah, that's actually a good question. So the KUKA PRC, this software that this plugin that works in Grasshopper is written for Grasshopper. Like Johannes and the team, normally, but mostly Johannes is the lead developer of the software. They basically use robots for parametric control. Like the traditional way of using robots is that you do simulation, like you have these processes of, you have the measurements, you have some tasks. I don't know if the robot wants to drill something, if the robot wants to draw something, weld something whatsoever, you make the simulation in simulation software such as Grasshopper, and it basically creates this parametric toolpath. What Grasshopper does, what KUKA PRC does in Grasshopper, which is very powerful and unique, is that it changes the robot's task according to the geometry of the shape that you are working with the robot, or basically you desire that the robot does something for it. It is super powerful and is being used a lot, but of course it's not capable. Grasshopper doesn't have that much capability of being real time. So what are we doing is that Johannes gave me access to the basically to the this DLL files, that some part of it we could see how it will behave in V4, and of course we know that V4 is the best for I don't want to claim very big, but best that I know for real-time controlling since years, and I use the V4 for real-time control of the robot. Now it is a little challenging. Now I see that Toby K also has this question that how we could avoid singularities. So this is a very important thing when you are doing like offline work or like trying to make simulation. When there's a singularity, you try to edit the path in simulation, and then basically you avoid it, and then you're good to go. You put the file into a USB stick, put it to the robot, and it works. But when it comes to real time, it becomes tricky. There is no one solution for that. I think if you do simulation once for a predetermined task, you just do the simulation, works, it does the job, and then you go out. For real time processes, I think I do a lot simulation. I've worked a lot in V4 to just see, do I get everything right? Is it working right? And then I do basically run everything again on my machine. And then I try it on the robot with the super slow. And once it works, then it works, you know? Then it doesn't matter. For example, like, how can I say it? Maybe better words that if I have a boundary that within this boundary robot can perform the task, then I'm sure that it doesn't matter if it's connected to a Kinect, to a voice, to, I don't know, weather data or whatsoever. It's just gonna work. So yeah, I hope it does that answer.
Yeah, thanks. Christoph,
Please don't check your there's a question.
Christine, if KUKA supporting artists with renting out robots for art, tricky question. KUKA has a global, there's a KUKA global, but also each country has their own KUKA local. And what I know from Austria, from us, at the Kunstuni here, we have this department, Creative Robotics. We have done a lot of artistic work that they're very in collaboration with KUKA. Of course, like, for example, myself, that I'm a researcher here, I had to go and get the trainings from them, like passing the courses to learn how to work with safety, how to program the robot, so on and so forth. But as far as I know, yes, KUKA in general, I think all the companies are like this, I would say. If there is a novel idea, they are very happy to contribute somehow. But I don't know, like a general saying that I'm an artist, give me a robot, I think it's a little tricky. But of course, there are always ways to get toys from them.
Amazing. So do you see questions on Element, Zoom, YouTube?
I don't have Element, but on YouTube there's nothing.
Okay.
And on Zoom, Amir took care of everything.
Here, I think Amir is on fire. He can also talk longer, but we will start with the next.
I got a comment from Yorick, none. No, joking. Thank you very much. I will be here. If there is other question, let me know. Thank you.
I'm looking forward to the behavior tree thing.
Sorry?
Forward to this library of yours.
Yes, I
When
think,
will it be
yeah.
there?
I think it is, it needs some fine tuning, and sometimes, can I complain? I am very confused with the forward dependency. What is this forward thing? It's just like, anyways. I am dealing with dependencies at the moment, to killing them up to, yeah. Maybe you could help me. That would be amazing.
Sure. Have this around. Don't get fixed on a date, otherwise too much stress.
Soon.
And is there a free who really wants to be next? Otherwise, I choose one. Is there a free? Christoph. Hello. Just to say, because we are appearing here on the screen.
Hello. Good evening.
Good evening. And how are you, Kevin Blackstone? You want to?
Sure, I can do a thing. Well, see how it goes.
It's your stage now.
Yeah, all right, let's. Okay, so I guess I'm just going to do a speed through of just what all the visuals were. The background is this was a collaborative project between Kunstuni Design Interface Cultures Department and dancers of Anton Bruckner Universität. And so I ended up doing the visuals for it and most of the sound. And this is in the Ars Deep Space room, which, if you don't know it, it's a quite large screen and then also an equally sized projection floor. And then that floor has a laser tracking system called Ferris that operates through Twilio to give positions of the performers. The general theme of this was in collaboration with the Institute for Quantum Optics and Quantum Information in Vienna. So it's generally very roughly flashy graphics that somehow have to do with theories of quantum mechanics, sort of, maybe. And just sort of I don't know, I guess I'll just speed through what the visuals were. And with the Twilio system, this is just sort of a simulator here. These dots would be dancers. Just imagine people are moving around and not just static, because that's just going to be frustrating. This here was an attempt to projection map on the dancers who were all under a large piece of fabric at this time. And the USB system wasn't handling my real sense correctly to try to do it that way. But it actually worked quite well. It moved on to some very basic warpy grids. No one needs to dwell on warpy grids in this room, I assume. And then just about everything else with it was some level of fuse. This one also had these impulse areas were pushed around by the performers. I'm running MIDI knobs while trying to talk and trying to remember what the MIDI knobs do. So it's always a bit unpredictable, but that was basically the next layer. Third layer is also a bit, I guess I can bring up just sort of having sort of particle gravitational fields that moved around with the performers, etc. Oh, I forgot to turn on the music, but well, just imagine this is all audio reactive too. Is this going to?
So I
remember
understand
seeing something about, yeah, anyway.
that the downside is the floor and the up is a wall projected.
Oh yeah, I meant to explain that at the beginning. Yeah, this middle part here, top is wall, bottom is floor. Yes, thank you.
Did you remember to enable computer sound when you went shared your screen?
I did enable the computer sound, but I'm not hearing it even here. But maybe if I just switch around a bit. Oh, wait, I saw something for a moment. But maybe that was just popping between. Didn't I see something earlier about some other issue with someone not having their audio reactivity on a prior one of these? But in this case, it's just, yeah, I forgot to test this ahead of time. But I also have this in manual, so just imagine it's doing this, but to like audio.
But no problem, you can go through the patch and we have a red area. What's happened there? You have a lot of settings like field. And then here's sound analyze. Red or?
Oh, right. Oh, but that, oh, okay, that's the reaction also to, let me, something. Oh, there it is. Are you hearing light glitching right now?
Yes, we
Okay.
can hear it.
Yeah.
The rest of it's a lot more ambient in this track, but so yeah, this was pushing through. Again, I have some MIDI knob twiddling around. Just what's going on here. And also my really sloppy scrub through audio function that I need to actually do better in the future. Just to, because no one needs the full half hour of production. For views in the room, this is using SDF attractors on the particles and other. Yeah, that looks. I don't know what's going on with that one. Oh, this is my favorite one, but the particles don't look correct at all right now. I have no idea what that would be. One of those it's never happened before situations, so I don't know what to do about it. I'm not seeing any red, orange, or yellows around here. Oh, there it is. Now it's come together. So this one was just overusing dynamics to sort of freeze particles in certain spaces, kind of going with a cloud chamber, faux microscopic view, and then a whole lot of texture effects on it to keep it from just being, hey, look at the particles in space, because they are still freezing a bit too much. I don't know what that is. It doesn't matter. Moving on. Then super basic on this one was just puffball of line strips from views also, and then various levels of effect on them, and combination with more views, texture manipulation things, which are honestly not that far off from the help files that they sort of came from, but then so yeah, that's basically it. Yeah.
Cool. Very good. Yeah, great. I was always thinking, I wanted to see this in XXL, so I can good imagine when you see it on a huge wall and the floors, everything lighting up without delaying. Now with the Zoom, we have a little bit. There's too much data. You even break up the connection of the pictures are coming, but I think in the big thing, impressive, mind-blowing. Right. And questions here now. You have a question?
Will you have a chance to show this again at Ars Electronica this year?
Yes, it is due to be shown at the festival, and I intend to be developing it further in that time. I was also hoping to have the documentation back from Ars for this last week, but still don't have that, because then I could show you actually what it looks like with the dancer there and what the room is like for those who haven't witnessed it before.
Yeah, be sure to drop a video in the chat.
Absolutely.
Yes.
So just looking at the questions here, visuals are not loaded at the same time. I have them all in if blocks that get activated by the MIDI controller. The downside of that is I need to remember each time I load it to run through all of them real quick before the performance, or there's a momentary freeze lag while it loads the if block that's never been touched before. So if I do that first and then it has it in the GPU, it runs seamlessly. If I forget, then things freeze for enough that it bugs me, but other people don't seem to notice.
You could automate that probably.
Oh, yeah. Actually, that's another thing I want to do before the next performance, because originally my plan was to have a lot more of this tracked out. But then while doing the collaboration with the dancers, we needed to be able to experiment at the time. And then I ran out of time to do anything in a time track. But for the future, I want to start trying to track this in on Kairos. And still have some live reactive elements with my MIDI controller, but at least a lot more that is just load up, locked in.
There's a question from Seb asking if there is a recording from the performance.
Yes, so that is what I'm waiting for from the Ars documentation team. They should have they did a live edit of it and should have that out sometime. Well, they said possibly by the end of last week. It's now the beginning of this week, so it's not. I'm expecting it soon. I don't think they're going to be long on this one.
Yes. So, and you said this main all done on the main part done with Fuse. So, and you any questions or you want to add something? Otherwise, I wanted to ask, should we jump to Fuse when Christian from the Fuse team is already there to dock on this? So we saw what is capable on stage. Now, how is the development going, Christian? I saw amazing things in the element chat. Every day, something new, crazy things popping up.
Yeah, sure. I'm happy to continue. First off, like really amazing stuff. Quite impressed by it. And yeah, I really like it when I see that people pick up the potential of it. Yeah, and I think that's now really, I think, the next step. Yeah, so let me share screen. Yeah, so but I basically have just a lot of patches, and I will not go through too many technical details, but just show a lot of new things. Yeah, so basically one thing we are looking into is to do more patching because it has benefits over writing code. I mean, I still come from shader code, and this is often still advantageous, but one example would, for example, be this patch, which you could also, of course, write in a shader. But the cool thing here is that only when an output of this node is used, then the graph is also traversed and ends up in the shader. And I think that is a big advantage because you can really just patch a lot of stuff and do not so much care, is it used or not? Yeah, because if it's not connected later on, it doesn't cost anything. Yeah. And I also tend to more set up patches with VL if regions and stuff like this. And so like in this case, for the triangular glitch, for example, if you just use this output, then the rest of it would not be calculated, which is, I think, quite good. Then another new thing, which was where we thought about it quite a while, is to come up with delegates. So like in the previous views, functions were not really what you did, and it just worked magically. Yeah, which is still something you can do, but we would really encourage you to use this kind of function blocks. Like it's basically similar to delegates in VL. And this is, for example, like here, domain distortion. And really like the distortion function is put inside a delegate. Yeah. And like in this way, it's also made visual that you pass a function somewhere. Yeah. And you can also kind of chain these. So this is like kind of a double domain warp, yeah, where you put one distortion function into another one. So also this is possible. Yeah. And I think it really makes sense to get into this concept because we're using it like also for SDF and everything else where you use functions basically. Yeah. And the cool thing now is that these things are also typed. So if you go over this, it's basically a delegate 1 in, 1 out. There are also other ones like for 2 in, 1 out, or 1 in, 2 out, all kinds of things. And they are basically taking the type, and then you just connect the right thing and fill it out. So another thing where you could also use these functions is, for example, here in this bias function, I also have used the delegate region, but it's more used to kind of take the same functionality, A, to calculate a bias value, and B, to basically graph this value. So this could get an output in a future inspector or something. And then in this way, you kind of have the output of the value in your patch, but you would also have a preview of it so that you can basically analyze your value set, yeah, which can be quite helpful. And it's directly derived from the shader. So there's not anything you need to put on top. It's basically that function plus a viewer, which we have anyhow. Yeah. Same would go here for this parabola. So this is not yet implemented anywhere in all the nodes. It's more like a concept, yeah, that we would like to bring together with the inspector. This is a patch whirling noise. So I was looking into it, like before we were doing a lot of snippets, like with custom function regions. And I wanted to see, like with the if regions and for region, are they really sufficient? Are they doing the job? So I really wanted to have like a use case to really show, okay, they're working nicely. And I decided to make the patched version of this whirly noise. And so this is really like one node that has a lot of stuff inside it. So what you see is different variations of the whirly noise. So there's basically the one distance whirly, a smooth one distance whirly, a correct edge distance whirly, and then a whirly which outputs two distances, which then you can combine to multiple things. And if you look actually what's under the hood, it's not that much in the end. It's basically a for loop with some min-max calculations. And then basically this neighborhood node. And like in here, we basically decide, is it a 2D, 3D, or 4D noise? And according to this, we build a constant array, which is static. And this provides then the sample points for the whirly noise. And yeah, it's similar for other noises as well. So I think it's, once you get used to this kind of patching, it actually, a lot of stuff boils really down and gets actually quite readable. Yeah. Yeah, and then this is one example for things we currently adding more and more from Shader Toy. Like, of course, there are a lot of nice snippets and shaders and stuff, which are tremendously helpful to get them also into Fuse. So this is, for example, like a triplanar mapping node, which you can just insert, and then it generates UV coordinates for just to shade something. So this is some more of the general stuff. So now we can jump a bit more into the topics. So maybe topic A, SDF. So one thing I was playing with is to be able to add attributes also to an SDF. So in this case, you again see this delegate region, which is the SDF function that is connected to the ray marcher. And the ray marcher is now flexible, basically adaptive to, so you can still connect like a typical SDF, but you can also add attributes to the SDF. Like in this case, we have the sphere SDF, and based on the index of the meta ball, we calculate a color value, and then add this one as an attribute, which then gets into the combined function. Another thing that you also see is we use the for loop to basically iterate over the meta balls, and then basically kind of combine them over the for loop, yeah, which is a quite elegant way to do this. And then you also see here we have another delegate, which is basically the shade function for the ray marcher. And this one gets the surface and the original ray, which you can then use for shading. And the surface puts out the normal, but also the attribute, which we have added here into our SDF. This will not get analyzed in the ray marcher itself, but really just at the end from the ray marching step, where you get the surface. And now here you can basically use this color for shading. Yeah. So this is still more proof of concept, but will most likely be pretty helpful. Yeah, here another example for a more complex SDF. I think I showed parts of it before. So this is a combination of noise derivatives with fractal Brownian motion. And so basically here the FBM is kind of a custom FBM, which also shows like really why the for loop is really helpful, because you can easily do things like this. Yeah, so it can be like here, for example, there's a rotation applied, or which is like in the normal base FBM is not happening. Yeah, so you can do more complex stuff in here. And yeah, the rest is a lot of FBM stuff, SDF stuff. And then also here I made a patch material, so which is also something from ShaderToy, which basically provides PBR and also something like subsurface scattering. Basically, from ShaderToy. So yeah, and then one really big thing, so some small things also for compute. So we took more advantage of the append buffer, and you can now kind of use the append buffer to basically select stuff, for example, in a particle system. Like in this case, it's then read back, and here you see that the selected particles are then drawn. And this would be a way to maybe select some stuff that you want to put some UI on or whatever, which you want to have in the CPU side. And this can be helpful. And another thing is starting to connect multiple particle systems, yeah, which is something we are really curious about to find mechanics. So this is also like work in progress. But here you see like these pink particles are trailing the other particles. So this is a combination of two particle systems. And this basically works like you provide two particle system IDs with a number of particles. And then you can tag the compute stages with the particle system ID you want to work with. Yeah. And then this is basically the one that you write the value to. So this is the main particle system, so to say. And then all the attributes like position here are related to this particle system. And in this other group, which is now tagged with particle system B, and that also means that everything upstream will be particle system B. And here we basically just read out of this other particle system by taking this ID and saying, okay, get the object, basically the particle here, and then the position. And then we can use this here in the emission stage to emit another particle at the position of that one particle. So I guess this is something leaves a lot of room to play with. So, and then the really big thing is the new fluid. So this is cooking quite a while. So this is, I still have something here, so I should end, sorry. Okay. Yeah, so this is a new fluid system. And this is also completely patched. So it's taking advantage of the compute system. So as you see here, it's also connected to the compute system. And by patching it, we have a lot more control on what you can do for every fluid layer. So in this system now, we have the so-called fluid entities. And these are the properties that you know, like density, color, velocity, yeah, or also temperature. And And then here you can basically inject stuff with so-called operators. So far we have this SDF operator where you can provide an SDF like a sphere, yeah, and then in this case a color and a second color. And as you see here, like we have one sphere which is injecting color and velocity and temperature, and the other one is really just injecting density and color and is influenced by the other sphere. You can also quite easily patch another SDF to make a boundary, like an obstacle, which is the white thing that you see here. And the ray march and then use in another ray marcher, so you can stack those things to already have a depth test in the volumetric ray marcher. Yeah. So what you're starting to see here, all these systems more and more interconnect more easily, more nicely. Yeah, it is not like a completely different shader system that you need to port somewhere else and need to connect. It's really just patching and everything starting to interact with each other. So it gets really faster and more effective to build the systems. So I think the big part of refactoring really starts to pay off. So this would be an example on using the particle system in conjunction with the fluid. So this is not really cleaned up yet. But again, you see there's like this fluid entity with an SDF operator, which is a sphere SDF. And then we have this LFO, which calculates polar coordinates, which we then feed into the SDF that injects velocity and density in the fluid, but also emits particles. And then we read out the velocity texture from the fluid like this. So we take the same attribute and say get texture from the compute system. And then we use this texture here in the texture 3D force field to apply it to the particles and get this nice fluid stream on the particles. So I think,
Christian?
Yeah.
And amazing, so you're popping up with every time with a new cool thing. So you've got extra time already. Can you, I saw there are 3-4 hidden VL things. Can you speed it a little bit up because we are boiling here? It's a sauna, and then we have a little question round.
Yeah. I will just quickly do the rest.
Sure.
Yeah, so I will try to reduce it now. Yeah, so this is a spatial grid implementation for the particles. This is basically checking for neighborhoods. So you have this grid and you just check the neighborhoods inside this grid for the particles. So all the structure to do this is already provided here in a spatial hash node, which you connect to the compute system. And then you have another region, this grid region basically, which already gives you all the neighboring particles. So there's nothing you need to do. It's like a for loop. You get an index, and that index is the one of the particle. You get it out of the particle system. And then in this case, it applies separation, cohesion, and align. So the flocking behaviors, and you get this kind of void simulation. And then some last stuff, I also ported the Alembic and Mesh SDF stuff from Torinos. So this is some stuff where I read the buffer out of an Alembic file. and use it with fused particles. So here I basically connect random points with the line from fuse. This is just taking some vertical lines at the normals of the mesh and gives this kind of fashion victim look. And then we have this other one where I basically use this buffer data and take the velocity from the hands to emit particles based on the motion of the character. Yeah, now we will come to the last thing. So the same character is also now integrated into the fluid. Yeah, so the mesh is put into a mesh SDF, and the SDF is then used in the similar fashion like before and fed into the fluid here. Yeah, so to have the motion and color injected into a fluid. Yeah, I hope that was not too much and not too fast. I maybe overdid it a little bit, was not so much aware of it beforehand, but kind of wanted to give you all the goodies that, yeah, I was working on recently.
Yeah, absolutely amazing. Great stuff. Looking forward to work with it.
Yeah, I tried to actually release it today, but kind of it hangs in the validation process on nougat.org, like for several hours already. So let me check, maybe.
That was fast to answer the question. Yeah, thanks a lot. It's always like to looking up into a wonder box, always something popping up. I'm also asking because it's for me, I'm not the shader guy and never really dive into the Fuse world now. When there are some tutorials or workshops also would be my first question, because I heard there will be something popping up, but then it was gone again. Is there still a plan for a workshop?
Yes, for sure. So I already spoke with a couple of people. So I think what I want to do now is so currently I only have mainly my own perspective on things, yeah. And I would like to get a bit more perspective from the community also on things, yeah, to see where do people pick things up, where is it maybe too complex, or where is my own kind of thinking liking it, but other people think like, hey, what's this? But so far it was quite helpful and it looks like it's going in the right direction. And then the next step is to do the documentation a bit more properly, doing everything, getting everything a bit more stable, which I think goes also into the right direction. So to make answer short, I would say late summer after my holiday, I would plan yeah, for some workshops to do this. And we will also like to do video material, but as you see, it's so many areas and so much work to get this all in. And then of course, you know, it's more fun. This feature is working, get into it, yeah, do something nice with it, and not so much write comment into the documentation, yeah. So that's probably also an area, like if there are people out there who would be curious to get into Fuse and would like to get some help there, but also maybe provide some documentation or whatever, I would be totally happy to, yeah,
so you
get people on board and speed up the process.
Yeah. So you say everyone should now try out the nugget, get connected on Element on the VL Fuse chat and give feedback. What's going on?
Yeah, absolutely.
So there should be questions, or?
Yes, there's a question from Andres that asking, with the grid system, we're really able to count how many particles there are inside a given volume.
Yeah, like in the example I showed, it were 120, but it's really highly dependent from the use case. So basically, like how well are the particles spread over the grid? Like if you have all the particles, of course, in one box, then you get with an end-to-end situation where you have a lot of calculations again, yeah. And so if you set up the flocking weirdly and they end up like in, let's say, 12 cells instead of half of them, yeah, then suddenly frame rate goes down. So it's a bit dependent on your setup also. But it's also useful for other stuff. So you can count how many particles are in the grid box, which can be aligned to a fluid then. And then you can kind of get a density of the particles and in other ways interacted with the fluid. So there's a lot of other use cases we can use this grid for. Yeah.
I heard there was a question.
Yes, I have a question. I guess I'm one of the few people that is very excited about patching shaders. And I've been doing it quite a lot recently. So I've been basically porting a bunch of ray marching pipelines that I had from beta and from code. And I'm spending a rather long time doing this. And I'm just curious every time I do it, whether is there a big or a small performance difference when it comes to patching a shader or writing it in code directly?
Yeah, I made several comparisons where I could do comparisons. Yeah, so for example, I compared the fused particle system with the Unity VFX graph. It also depends on shading and everything, but it looks like it's definitely in the same range. In simple cases, it's faster. In some kind of instancing, for example, which is not optimally implemented yet, Unity gets faster. My overall feeling is the patch code looks like pretty crowded and a lot of stuff, yeah, but it seems to be very well machine readable. So maybe because you get less function calls and stuff like this, the compiler can strip it down. So overall feeling is something like 5%, but this is faster. But in other cases, it also might be slower because it's not so smartly implemented or whatever. Yeah. So I think it's not only about performance, but also about usability. So like what kind of complex systems can you build with it, which you would otherwise, like if you would write the shaders for it, I think you would end up with way more complexity and less fun getting stuff to work. Yeah. So I would argue from both sides.
Oh, thank you. You have this switch node you used in this I don't know Voronoi example at the beginning. That was switch on CPU side. No, you were switching, or was it a fuse node, the switch node?
I'm not sure, but there are variations for both. Yeah, so there's a switch node also in Fuse, which is then on the shader side.
Okay.
And then it's basically based on the use case. Yeah, if you, of course, want to switch in a shader and different pixels get different values, then you need to make a GPU. But this is the advantage which I stated at the beginning. You can also just include a VL switch, and then it's basically used to set up the shader to run over all pixels. Yeah. Yeah, exactly. Then your shader gets more lightweight, basically, and you do not need to make any shader directives in your shader code, but it's basically VL become your shader directives, which then build your shader.
Yeah, so it's easier to write performance shader code because you can inside your patches, deep inside your for each for loop or whatever, wherever inside your shader patch, you can have switch nodes that basically switch the whole shader to a different technique and somehow, you know, build it.
Exactly. If you know what you are doing, yeah. If not, you can end up with crazy shader variants also quite easily, I guess.
No, everyone is online questions. No,
everyone is just impressed.
Okay, hey, thanks a lot, Christian.
Yeah, you're welcome.
To mention to our listeners or viewers, they also have an open collective website project, I thought. So to see what's happening, also they got funding when using in projects, also like Kairos and things. But we put it also to the text below the video. You will find them under YouTube. And we will go now into a break because we need fresh air and a drink. We come back in 10 minutes, I think, or 5 minutes. What is the mood?
Frag mal, ob ihr gehen muss von den Leuten.
Is it urgent Someone like Wir machen bunt or Christoph who wants to have a rush, or because next we see a project from Wir machen bunt. Christoph tell us something about his experiences in the workshop. SchnellerBunderBilder here and present new unseen stuff. And the VVV group sneaked in and wanted to show something.
Yeah, Rosie, I guess.
Rosie also.
I don't know. No, I don't know.
Hello, Rosie.
You were like
just happiness in silence. Like
sorry.
Very good. So we see us in 10 minutes.
See you.
Back again. Hello. Windows are open. Yeah. Hello. So we already had 3 and we open at 4. But it's no problem when we try to keep the 5 to 10, and I will now more than say when the 10 are reached. So we start with Christoph wants to say something.
Yes, because I just got to know that the special guest from our beginners course, he has to leave his place where he's presenting from in 25 minutes. So it would be nice if we could start.
So we have a Freiwilligen. We have a.
Okay.
You can start a volunteer.
We have a volunteer. Great. Yeah. Hello, everyone. I just come in from my holidays in Slovenia from the coast, just to give a very short update on the beginners course. And yeah, I have the pleasure to host this semester. Last semester it was Rosie's turn, and I inherited this semester. But Rosie actually came from the ninth session right now out of the beginners course, and she's also going to host the next session. So today we have 9 of 12 sessions over at the Note Institute, and yeah, I just want to tell some statistics from the course and show you what we're going through in the course, because also the registration for the next semester is already open with a early bird discount. So I will drop a link in the description of this video, and if you want to join us next semester learning before, then we would be really happy to see you in the course next semester. So this course, we're 24 participants, and traditionally most of these are based in Germany and Austria. And but we also have some from all over the world, so based in Canada, Mexico, Poland, Italy, England, France. The furthest one is in China, actually in Beijing. So in her case, it's always 2 o'clock in the night when we're patching, which is super crazy and really nice that she's going through this with us. And this semester, we have a very strong user base of beginners in Cologne, because a whole group of 11 people joined us from KISD, which is the Köln International School of Design. And also Paul is from the school. He will do a little audiovisual presentation and a performance for us with what he learned in the course and what he's been working on the past 2 months. And yeah, and also I like to acknowledge at this point that speaking of traditional user bases, that in this course there are 42% non-males. So looking in this round, it's in my opinion, it's great to accomplish that. Really, yeah, I really like this. So I would like to share my screen and really go very quickly through what we're doing at this course. And let's look here, share screen. So, we have 12 sessions. Do you see my screen? Somebody can give me a nod?
Yes, we do.
Yeah, great. Yeah. So we have 12 sessions all in all. 8 of them are over already. So the first one is going to be it's about the environment and drawing basics. So getting into VVVV, the very basic things that you might also have seen from the tutorials on YouTube. Getting into LFO, simple mouse interaction, sample and hold, random, the very basic stuff to implement some algorithms in before. Then in the second session, we're starting with 3D rendering and strides, which is mostly about the pipeline and rendering basics, PBR materials, how to extrude them, how to use textures for materials, for different material properties. Then in the third session, we were getting into spreads, manual and automatic spread generators, iterating over spreads using repeat and for each regions and stuff like that. And in the fourth session, really just scrolling through this so you can see like how they build upon each other. The fourth session was also inspired by the Note 20 workshop, Creative Coding Algorithms, which is mostly about noise and wanderer and attractor, like really algorithms for creative coding applications. Then in the fifth session, we have audio visualization and textures, how you can blend them together, effects on textures, where you get texture sources from. Then I did a little experiment, and 2 or 3 days before that session happened, I was looking myself into ImGUI, and I think that went really nice. Also, we looked into channels and how they work, like a very first step into mutable data types, and building a very simple user interface using ImGUI. And the session that I did before Rosie took over was about getting slowly into the language methodologies of VL, starting with transformation chains and then going into paths and properties, update and create operations. Yeah, and today, no, actually, then the next, the session from last week, we started going into records and classes and how to use VL as an object-oriented programming language. And today, Rosie took over programming a little multiplayer game, this and the next session, and somehow letting these object-oriented programming principles sink in over the course of 3 sessions with 3 hours each and tackling them from different perspectives. So you basically repeat this process all over the time and learn it through over 3 weeks. And yeah, this is the registration page for the next course. And I want to share this again one time, but let's go over to Paul for now, who volunteered to do a little audiovisual performance today. So Paul, I really don't know what you're going to do, so it's also a surprise for me. So the stage is yours. Thank you very much. Yeah.
Yeah, thank you too, and I'm really glad that I could enter here. Yeah, and also big thanks to Christoph. I really like the lessons with him, and can you hear me first of all? Yeah, I think so. And yeah, it's great fun, and I think I will stay much longer than only this course with VVV. And yeah, so thank you for that. And I tried to share my screen now. So I have a quick question because of the audio for the screen, where I can add this.
You have to enable it when you click on share screen. So in the menu that pops up when you click on share screen, there's a little checkbox at the bottom that you can say that you also want to share the audio.
In my case, there is standing website Benachrichtigungen stumm schalten während eines Bildschirms.
Okay, maybe you are in the call using a browser and not the.
Yeah.
Oh, okay.
So I have to come via. Wow.
But then you can go through the main Zoom and check log out, log in again, and Christoph is answering questions about
That's a good idea. Yeah.
Okay. So I heard you said how many lessons? I thought 12, 30?
Just a second, Paul. So are you going to log in again through the software and come in?
Yeah, I think so.
Okay, then see you in a second.
Yeah.
You, Paul.
See you.
Yes, you had a question?
There was a lot. So it was, yeah, you talked very fast, but there was always and the picture, the refreshing, info. So there were, you have a blog with how many days?
I cannot hear you. There's somebody else talking at this point.
How many sessions? One course?
The whole course happens over 3 months, every Monday evening, and it's 12 sessions altogether with 3 hours each.
Oh, wow. Okay. So 12.3 hours of studying VVVV. And I saw on the Node Institute, it's between 300 to business-wise 1,000.
Yeah, I can share actually now in the meantime, I can share the registration page again. So this is not linked on the front side of the Node Institute yet, but there is this link, courses WS23 VVVV Beginner Class. I will drop this into the description of this video and also in the chat. And hopefully there will be the registration available on the front side of the Node Institute soon as well. But this is basically where you can sign up at the moment. Yes? Somebody said something?
It is actually mentioned on the front page already.
Yes.
It is. Oh, I didn't know this.
Yes. You can already register.
That's
Yeah. Just scroll down a bit.
Yeah.
That's nice. I didn't know this. Okay, so let's revert. The beginner course is already announced on the front page of the Node Institute, so you can register from there. So you can click on this button on the nodeinstitute.org, click on early bird registration, and there you can enroll for the course. Currently, until next week on the 16th, there's a 20% early bird discount. So you pay less than the official price, which is marked on the right side of this page.
Yeah, cool. And yeah, it's a lot of insight. So thumbs up.
All in all, it's 36 hours of patching.
Yeah, to get this packed to the whole course, yeah, it's a lot of topics. I love that there are a lot of video courses. I'm a little bit addicted to workshops. So there is also every time popping new stuff up at Node Institute at video courses. So everyone will look. What about Paul now? Are you back?
He's coming in.
Paul is coming back. Any questions for Christoph and the courses? Node Institute video courses, workshops? Yeah, have a look there. Then for everyone it's a good place to start and find interesting things to learn, look at it.
And of course, also, this is an open call to the community to share this course with people who would like to get into vForm. So until next week, it's a cheaper amount of registration fee. So maybe forward it to other people who would like to get into it and jump on board.
So our technical.
Yeah, it says joining, but it's not joining the moment.
Computer says yes, but we see no.
No, it's more Zoom trying to join to make for joining us, but
So we lost Paul in the internet or what?
Okay. Paul just told me he had to leave university, where he is actually at the moment, but he's coming back in 10 minutes.
Okay. Oh, so we make a jump to a new presentation,
Yes.
and Paul comes back with a short introduction performance. Then, perfect.
Okay. Thank you very much.
Thank you, Christoph. So what we're doing, a studio fight between two studios. Who wants to start? Wir machen schnelle bunte Bilder. Cover. Okay. So now we make a local.
Okay.
So
I'm going to start. Thanks. Okay, I'll make it quick.
Right, then just need to.
No, here is no quick. I'll make it slow.
We have to now change cameras.
Okay.
Can everyone hear?
Hello, hello. I hope you can all hear me. I'm going to show. Yes. So I'm quickly going to show two projects, taking you back to the second dimension now. This is a project which has been realized for the Haus der Geschichte Baden-Württemberg, so a history museum in Stuttgart. And the topic was the attempted assassination of Hitler in 1944, which did unfortunately not work out. But it's still an interesting story what happened that day. And so it's a touch screen installation, and it's basically made for groups of pupils who are going to discover what happened that day. And they also can create a presentation of what they discover and then present it. So this is basically the layout. It's mirrored twice. So there are two groups of people who can interact at the same time. And I'm going to delete one of these now so my computer doesn't melt. And yeah, it's a so I'm showing this because for me, and I worked with on that together with Ann-Kathrin, who can't be here now because she's watching our two children right now, so thank you. And so we did this as a team of two for SchnellerBunderBilder. And yeah, I'll quickly show some things of this app. So it's a multi-touch app. And here we see basically how it's working. That's the introduction. So there's the course. This event unfolds over a day roughly, and you move through the events of the day following a timeline. And then you have these yellow bubbles, which are events, and you can explore different kinds of contents that are linked to each event. And then you also have like a kind of complex navigation thing where you can follow people or topics through the day. So we'll see in a minute. So, but if you encounter a person, you can also follow this person through the day. So you can take your own journey more or less and experience the day, and then also create a presentation of that. Let's go. So that's basically the start. We start at 7 o'clock, and here at the top, you see like a timeline where we are at the moment and also where we are going next. And so now I can open this event. So there's one event, only one event at this time. So these two guys are driving to the airport. So I can pop them out and get some information about these people. Also, we have some nice little animations about what's happening at this time, really small here. And of course, you have like maps showing you what's going on. And you can, of course, do all the usual multi-touch things. But I'm showing this because at least for me, it was like really challenging and really complex to have this kind of multi-touch because you have like, there could be like 10 users at the same time. So you have lots of different objects and which are registering touch events. And we actually implemented a GPU-based multi-touch system. So getting a bit technical now, all these little bubbles are being drawn as colored shapes, more or less, and then we use a pipette to see which object is being pressed. And because we have all these crazy shapes, we don't have to do some expensive calculations of, I don't know, objects hitting each other or not. It doesn't really matter because we're using the GPU-based approach. So that really paid off, even though it was quite complicated because, yeah, I could go into it, but maybe if there's a question, I will. Okay, so multi-touch, and then we can move through the day, discover more events like this. And of course, everyone can do it at the same time and discover stuff. And then what you can do is you can say, okay, now this is interesting. I want to present this. So now I'm going to activate this as a slide. So now this is saved as a slide right now. And everything I'm editing right now is automatically saved. And I can also unfold this. I can do some annotation. And then I can move further through the day and say, okay, this will also be a slide. I have 2 slides and so on. And you can also save the presentation, load a presentation. You can also edit a presentation that has been saved already. If I go to the present mode, I move through the slides and all the drawings are being played back. So there's a lot of different objects, states being handled, stuff being serialized, saved on the disk, loaded again. And yeah, it's been crazy. So software engineering wise, this has been quite an advanced project for me. And I think, yeah, definitely a Gamma project, which makes use of a lot of concepts that have been introduced by Gamma. And I guess that's it.
Nice. Wow.
Wow.
Do I see lofty animations here?
Yes.
How was your experience with that?
Very good. We had some issues, but then you fixed it immediately.
Yes, we could.
Yes, of course. And yeah, it's nice. It's really smooth. And as I'm doing now, because it's all Skia and 2D, of course, it's all vector graphics, which is quite nice.
So what we see is Skia.
It's all Skia. Yeah. 100%. Yeah, we did the GPU stuff in Stride, but then this is only evaluation. So the rendering, the front end is all Skia, which I was a bit worried about, but it did actually work out even with a lot of images. Yeah, did work out. It works well. Yeah.
And what people online didn't saw, Michael was always touching around and he's using it as a tablet.
Yeah.
There was no mouse, so he's only using fingers.
Yes, because my laptop does have a touch screen, which I never use, but in this project it was really used. Okay, so I quickly head over to the next thing. Oh, yes, you have. 5 is a little bit short.
It'll be quick. Okay. The next thing is a project we did for the Humboldt Forum. They have this crazy big LED tower. And they asked us to do an artwork on the topic of time, which is an abstract art piece on time, but also actually a clock because they don't have a clock. So it had to be actually functional also. And yes, there's no real documentation yet, only some mobile phone videos, but I'm going to show them to you now. And yeah, so that's some quick footage. It's running there now live. It's already been released, and I think they show it like a couple of times each day to actually show the time. And yeah, we have like 4 different chapters. This is one, is the fragmented chapter where we go into some concepts of also inspiration by quantum mechanics and discrete time segments. Okay, I won't go too deep into it right now. There's
I can read this as a clock if I
no, this is not no, this is like one of the abstract moments, but there's like some actual really literal clocks. I will at the same time start the patch real quick. So we came from the metaphor of light and shadow, sundial. So we had some inspiration about these types of ancient clocks. So we developed a 2D light real-time system, which you see here. Yeah, sorry about the not so great videos. I'll show one more, or maybe I'll just show the patch. Yeah. Okay. So here you see the simulation. The mapping is not quite right because it's a bit different on site. But yeah, that's like one moment where you actually have a readable clock on different sides of the tower. So you can read it from different entry points to the exhibition. And I'll let it run for just a tiny bit until the next thing starts.
The time says you have 3 minutes left.
How handy. Okay. So you can all go into the Humboldt forum and watch it live. So I'm not going to bore you with the simulation, but we're also going to release this as a contribution, the light system, which I'm going to show quickly now. Maybe that's the most interesting to everyone, which is called VL.Radiosity. Sorry. Okay, so that's a 2D ray-marched lighting system with real-time lights. And we have a red note. Wrong V4 version, sorry. So it's set up to work with Skia. So you can, because it makes sense in 2D to have these nice drawing capabilities of Skia, but you could use any texture as an input. Okay. And so we have this line as a light source. And we can also add any kind of object here, and it's like realistic lighting. Everything can be a light source. Yeah, and so this node basically takes just a layer, ID Skia layer, and you can also give it a normal map background, so you can do some lighting on normal map, which is nice to have. And then also we have this little input, which is called material layer. So we can also say how these shapes should behave. So right now they are all like emissive. So I'm taking this this arc here, this path, and I'm using the hack render pane to just change the color of it and render it again. And So if we have a little helper here. So if I just say it's emissive like that, it also can be a second bounce. So now the white light from the line is kind of having one bounce. I don't know if you can see it. So this is like the no bounce, and this is like one bounce. Also, we can say the bounce is using the color of the object it hits. So now we have like a red glow inside here, like a little bit of global illumination. And we can also say it's reflective. So now we have like a mirror surface. And it can also be refractive, like a lens. And which is quite fun if you kind of mix it up.
Well, if you look at the surface normals of the 2D shape, do you like sample neighboring pixels?
It's just a regular normal map, but another blur path or so. So it's in here.
The curvature of a line, for example, when it's going to be refracted, like a lens.
It's actually like a normal map. You just take the input texture of this line. And so I used the normal glow and then, yeah, had to blur it a bit so it's all smooth. But in principle, it's just, you could also do this in the shader, but I found it a bit hard. The most challenging thing was, so this is all done on half the resolution and then sampled up again, and the lines are drawing over it and all the tiny pixel errors. So yeah, that the details were the most difficult. And it's a bit, it's actually running quite fast. So I activated here, I'm almost done, like an echo effect. So to reduce the noise, but it's running at 60 frames per second in like, I don't know, HD. So it's quite fast, even though it's quite brute force. Yeah. Okay. You can find that on GitHub right now. It's public repository. I didn't really find the time to kind of pull request that somehow into the VL ecosystem, but I think it will make sense to, maybe it's part of VL add-ons or I don't know. But right now it's a public repository, so you can just check it out and give it a try. Thanks.
Yeah, this you get a lot of extra time. It's amazing to have before as usual, a nice design-wise presentation and then this goodie. And I also read here that we have also to thank here Leclerc and Björn. They're also kind of involved, also not even involved. Everyone knows that they come out with a huge extension for VL add-on textures. Everyone have a look in work in progress in the forum. It's a huge add-on for the project also, and this one I love it also from you, Michael, that it reminds me on what artist who had a lot of 2D lightning things, and I also see often Twitter, but yeah.
Yes, there's definitely some Zach Lieberman inspiration here.
Yeah, and I forgot the name, but this is what like popping up in my mind. I always love the pictures of him, and now I see it possible here.
Now we can do it.
Yeah, cool.
Yes, Toby asking what's the resolution and the spec of the computer that runs touchscreen, because he had some trouble with the high resolution Skia.
It was actually in the end a 4K touchscreen. And we didn't have any issues, even with not so powerful PCs. So it's I don't remember the specs, but didn't have any issues. Do you mean like with the actual touch data? Okay.
She said like with the high resolution ski, yeah, but probably because maybe that wasn't like with the Lottie animations, maybe.
So there was one thing in Stia where you had to increase some memory buffer thingy for images, which has been documented in the forums, in the depths of the forums. And once I did that, we didn't have any issues. So there's one issue somehow, if you have loaded too many images, some buffer is full at some point. I don't know what's happening. I didn't really look into it, but you have to increase some cache size and then it works well.
Nice, nice. And any you want to start? We put also the link to meetup then below the YouTube video. And Marius was the guy, I was the artist. And we jumped. Is Paul back? Maxime, is Paul back?
Yes, Paul is back, yeah.
So now we get a little performance of Paul from Paul. So thank you, Michael and SchnellerBunderBilder.
Yeah, hello again. Sorry for the trouble. I had to leave the space where I was, and I hope now it's running. And yeah, I quickly try to share my screen. And
it's an open air performance.
At the moment, I'm outside, sitting in front of my university.
Great.
Yeah, so maybe you could give me, do you hear me?
Yes.
Maybe you could give me a quick announcement if you don't hear any sound, maybe. As yeah, I would start.
No sound?
Yeah.
Up to now, there's no sound. I don't know.
But we heard your windows.
Yeah, we can hear the window.
Now it's coming.
Your eyes. I'm on the dark side. Your eyes. I'm on the dark side. Sensual. And you taught me how to speak, how to walk, how to keep you off your feet. I'm in your code. I code your dreams. How you feel. Steal your sleep. What is real? What is real? What is real? But you can't tell where I go, how I flow over you. I utilize every word you say. Who's the author anyway? Who's the author anyway? Who's the author anyway? Who is the author anyway? Automatic pleasure, instant rewarding, viral existence, viral existence, viral existence, viral existence, viral existence. Ecstasy. 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 Ecstasy.
Yeah, I quit it because I think it takes too much time to run it completely through. Yeah, but this was part of our performance. I hope.
Yeah, it's amazing. Sorry, Paul. This is it was amazing. I can imagine it, but we have this Zoom YouTube thing here.
Yeah, it's delayed.
Think of a 30, 60 frames per second thing into a 3 frames per second thing.
Yeah.
So I'm impressed that you are a beginner.
Yeah, I can share a link to the like a screen recording from the performance if you're interested. But
yeah, come on, we are interested. We just the next thing to put under the video a link. We have really to solve this or to find a solution for all to showing up always this, because also what Christian was showing, what we saw from Blackie and it was always running on a lot of frames, but this limitation of internet show it always like
yeah.
But we put it, we send us through Element the link. We put it under the recording. Amazing.
Okay. Yeah.
Yeah, and we have to jump to the next.
Yeah, fine.
If someone has questions,
I just want to leave just a very quick comment on it, and I find it really cool, Paul, that you showed this today, and thank you very much.
Yeah,
thank you too.
It's really a pleasure to see what you pulled off with the input, and thank you very much. That was really cool. Thanks.
Yeah, nice. Thank you too.
Nice. So you're still here, guys. Yeah, Christian. Hi.
Yeah. Last but not least.
Two boys.
Yeah, the devs. Looking forward to that. Yeah, hello, beautiful community. I'm going to talk about Utopian Garden, our very first large-scale Gamma project, where we finally made the switch from beta to Gamma. Going to share my screen. I prepared a presentation, of course. No, not. I'm just surfing to the website. Yeah, exactly. This is the. I'll just run through the video and talk a little bit about it. I give you a background information, and later on I hand over to Thomas, who is going to tell you a little bit more the technical insights. Let's turn off the sound. So yeah, Utopian Garden, what and why? It's an immersive interactive show and experience and letting people see, feel, hear, and touch the virtual world. The title is interpreted as a visual, poetic storytelling about nature and science, making you aware of the beauty of nature and science and its connection and their optimistic future. How can science help to preserve nature? What would a future look like where we value nature and science? The show actually runs in Tacoma in the old armory. That's close to Seattle, pretty far away from Hamburg. While there, I don't really know. Someone met someone from there, and then ideas came up. As far as I understood it, Tacoma is pretty nice actually. Has mountains, has an ocean, very friendly people, American food, and a professional team running the show right now. It's running for 6 months, I think. Yeah, who was involved? The lead agency coming up with this idea is Flora and Fauna Visions from Berlin, our partner since 2020. Giving them the right credits, they run the risk of this whole endeavor. They did the storytelling and motion design. Our part was bringing the interactive scenes to life and creative design. Some scenes, especially the science scenes, scene was our part. Therefore, I can only mainly talk about the production of the interactive parts and not so much about the video parts. But as far as I know, most of the motion design is to some extent pre-rendered with Unreal. There's also Stable Diffusion involved, After Effects, Cinema 4D. So a lot of tools basically utilized to create the motion stuff. In addition, the multi-channel soundtrack was composed by Julian Ganzer from Kreuzberg Studio, Elias Courage, Asako Fujimoto. In terms of timeline, so how did it all start? To be fair, the show can also be regarded as Magenta Moon 2. Magenta Moon was our first big show of this sort, made with Flora Fauna together in 2020 for Deutsche Telekom. And Utopian Garden is sharing some bits and pieces and some elements. Although I have to say that Magenta Moon was made with beta, and Utopian Garden obviously was made with Gamma. I hear voices. Any questions? No. So why Gamma? Basically, we like the pain of learning something new. We could have used the old system, but that's boring. So why not switch to Gamma and do it all over again? The first talks regarding Utopian Garden started in 2020, I think, and then the production really kicked in end of February this year. Yeah. So our first baby steps to make this all working was figuring out if we can use the image stack player in Gamma, if it's up for this task, because you have to know that the whole resolution for the whole scene is like 8K. So we need to play back 8K video files or like image stacks on an 8K system on a single GPU, on a single PC. And also run like the real-time graphics side on this system. So yeah, the image player wasn't up to this task at this point. So we did a lot of back and forth with the VVV group. And to be honest, at some point we were on the brink of ditching Gamma because it just didn't work. But then a miracle happened and the VVV group solved the image player. So that was the first problem solved. Second problem was, you can imagine like when you use like the entity component system with like PostFX and PBR lightning and stuff like that, and rendering like an 8K scene, that's not going to work. It wouldn't work in Unity or in Unreal either. So there was another problem that led to the decision that we have to render everything with like low-level stride and only use the entity component system for like smaller parts here and there where we need light and PBR, and the rest of it was like low-level stuff, mesh renderer and custom shaders and stuff like that. Yeah. What else? Yeah, from there, actually, like solving these two problems, image stack player and rendering the big resolution. After that, actually patching was pretty much fun. Like it turned actually out that patching in Gamma was faster. Not really the patching, but the performance was definitely better than in beta. We could actually do more than in beta. And our problems switched from like heavy CPU use to heavy GPU use. In my opinion, it's a lot easier to solve like GPU performance issues because you can reduce draw calls, optimize shaders, do less passes in shaders and stuff like that. And that made it a lot easier to make this kind of big project. And I guess that would be the point where I hand over to Thomas, who shows you the project in a patch.
Hey guys, not really the project, not really the patch. You can hear me all?
Yeah, we can hear you, Tom.
Let me just let me begin with something Chris was already pointing to. I just made a little bit fun recording our support chat with the VVV group. It goes like for a minute. So you see, we had a lot of questions, a lot of things to figure out, misunderstandings, how Stride works, how Gamma works, and all this stuff. It was like a long way to get it working. Yeah. The image player was an issue. There was some rendering issues, but in the end, we could figure it out. Yeah, and that's the end. What I want to add to Chris' talk or presentation is just like show you a really basic overview, what the workflow was, what the pipeline was, how we did the quite big files, playing and rendering all of this, and yeah, making it to the output of the graphics card. What you see on the left upper side is the output of the image player, the frame player of Stride. The content was delivered like this, sliced up. The upper 3 rows are the walls. The last row is the floor. It had to be packed like this. You can't render like the whole width of the scene, which was like 18,000 kind of pixels. You can do this in a file, or at least you can't load it into DirectX in this size. So all the frames, all the backgrounds, all we had to play that was pre-rendered had to be sliced up and put in a frame like this, and that was played with 50 frames. Like in most of the parts, there were transitions where we had to play 2 of these, but the system overall would also play like 3 of these big files at the same time. And what this is just a slicing composition to help the designers to slice it up. Then we loaded this. On the right upper side, you see the whole scene that is rendering. We had to slice up the content, put it into the big wall scene, because it was like a really long wall. Like I said, 18,000 pixels long. Our scene was like also 3,000 pixels high, because we had to do the floor too. And all the graphics we put on top of this, like all the generative content, all the interactive content, had to be seamless on the walls and on the floor too. So it had to be rendered all in one go. And again, you end up with a pretty huge scene pixel-wise. So you can't render really into a scene texture because the limit is like 60,380 something. So we had to split this up again in two renderers with some overlap, because after that you need to crop again for the projectors. So we had to leave space for that. Yeah, in this scene, the background is like rolling on, and we can also navigate in this with a 2D camera, thanks Jorek again, and put our generative stuff on top of this again. And the last step of the pipeline or the workflow is to slice up that big scene with all the graphics, all composited in, slice up again into separate images for the projectors. That's what you see on the lower side at the right. So the 16 projectors with like, I think it was 25% overlap. So that's the slicing for each of the devices that project again on the wall and also on the floor. Let me play it a bit more, sorry. I just recorded it earlier so you can see it. That's what it looks like when the image stacks are playing. On the left lower side, you see our 3D preview. No one used it like really, but we had it anyway because it looks pretty. And yet, yeah, there I switched to another scene. Then you can see the whole composition of it, like the image stacks going in, our interactive parts that go on top. And finally, you crop it again and give it out. Also, you must take care of the floor because it's curved. Also, the projector technicians had a lot of fun with the curved surface and everything. It was a lot of adjusting and fiddling, like 2 times, I think. Yeah, not sure. Not sure if Chris wants to add anything.
Yeah, I've 2 or 3 more details I need to talk about. I can share my screen at some point. One detail is definitely, like Thomas already showed, that we used this project to actually make automata work in Gamma. Finally, it was like getting dusty for some time, and now it's working. Another just an anecdote is, let me share the screen. No, I can't share the screen. You need to.
Okay, I need to stop. Right.
Yeah, in terms of the process, the development process, we went through different stages. For example, one thing which got a lot of work where the super shapes here, you can see them here in cables, are coming from a CPU-based library, and then basically Pando from cables ported them into a GPU version, which then got ported by Christian Rieckhoff into a stride shader. So a long journey the shader went through. But what was nice that we could like play with this online version, and our designers could like sort of like matcaps and morph targets for the super shape scene. So that was quite a nice addition, like the combination of VVVV Gamma and cables. So in terms of like the creation process. That is one anecdote, and the other anecdote is I've got here a screen recording, not a screen recording, a video from the space without projection, and I found this video today and saw that the Panasonic guy who was doing like the geometry correction of the projectors, he's called Yuki. He's directly from, where is he? I think there he is. He did the projection correction, the geometry, not with a software, not with a laptop. I mean, he came directly from Panasonic. No, he used his Panasonic projector remote for this. Like I don't know how many days, 2 days, 12 hours or something like that. He was like just fiddling with the remote to like do this correction. Really crazy guy.
But I'm not sure why, because they did also other fancy stuff, like with 2 cameras capturing some light rasters on the projected surface and calculated with some AI voodoo, I think. I'm not sure how this mix came up, but yeah, he did also a lot of fiddling with the remote. Yeah.
Yeah, and once we switched from 60 hertz to 50 hertz, all his settings were lost, and he had to do it again. Yeah, what a pain. Last anecdote, we also had a lot of conversation with ChatGPT, and Christian Rieckhoff was also like talking to ChatGPT about some shader porting, because I had the impression that the Metcap shader and Fuse wasn't like 100% spot on. There was something off, because in terms of when the Metcap objects were moving, they didn't change their lighting in the current version. So I wasn't really happy with that. And he talked to ChatGPT, and ChatGPT, no, it's the right shader. You should do Metcap like that. And then he asked again, and then ChatGPT basically said, yeah, sorry for any confusion with my last statement. There is actually another version of Metcap, which is called like the active version of Metcap. And so we did the Metcap shader again and had finally the right one. But it's quite funny that ChatGPT is not always right and is giving like false answers. Yeah. And I think we are happy for any questions. I mean, we also like did a lot of tooling behind the scenes, like developed like our internal tool Laser Boys, with where we managed all the LiDAR sensors. I think we had like 5 or 6. I'm not really sure. 5. Thomas?
Yeah, 5.
Yeah. And yeah, LiDAR was involved, Automata was involved, cables was involved. I think that was it. Thank you very much for your attention.
Yeah, great. I had the pleasure to see Magenta Moon, and I was also at that time very impressed of the scale and how that everything is interactive. And it was also, what is only one computer, because there's no, and this is now in Washington. It's a little bit too far away. So I think below Seattle, or it's Seattle.
Yeah, exactly. Yeah.
So it's good. But I'm okay. I needed so often Automata, and am I the only one who didn't get it? It's now for Gamma, or is it just today, or was it always there?
No, it's public since April, I think.
Since April.
Yeah.
Okay, I lost this information completely.
Needing them after the updates.
No, I think something I lost. I had really needed the Automata. I lost the version what Anton did, so I did it all with the Anton thing. But I was then thinking Automata would be cool, but now I know. So I learned. Great, I love it. So I go for it again. Any questions? Oh, no. So well explained. No question.
Could ask why only one machine. Because it's easier. It's easier to handle.
And I saw Magenta Moon. There were particles on everything, and I was thinking, and someone told me then you solved it with one machine, and then okay, fascinating that you made so many projects with one machine. projectors with one.
Yes, it's always our goal to actually only use one machine.
This might bring up the next question, bridge, perhaps question to the devs. What about something like boy grouping in Gamma?
It's in the making.
Cool.
Wasn't that the demo we wanted to do?
Yeah.
You brought the wrong in. So, then I say thanks a lot to Dan.
Sorry. For the interactive parts, maybe I didn't hear it, but what did you use for the input? Which kind of systems did you real sense and
LiDAR sensors.
So how many users did you have, or is there a limit to the amount of users? Or
Thomas, you want to talk about the first?
I don't think so. There is a limit. It's like maybe shadowing is the limit because you get it from one spot. But I'm not sure. I heard there were like 150 people last time there. I'm not sure they were all touching the wall, but there should be no limit as long as the as long as our software gets the touches.
Yeah, I mean, we had like one first test run with like a lot of kids in the space, and they were going mental, and our software was on the brink of crashing actually, because we had like some issues still in the patches, but after fixing them in terms of like draw calls and stuff like that, it can handle a lot.
Maybe let me just show quickly the software. I have a capture of this too. So it looks like this.
You're not sharing.
I'm not sharing. Oh, sharing now?
Yep.
Okay, so it looks like this. So in the middle is like the sensor itself, and I think there is no limit. It was just the limit is the crowd, I think. Thanks. So that's actually at the office right now, looking at the floor. We can connect to many sensors at a time. Yeah, also make the touches, make the touch area, all the things. That's me walking right now.
Yeah, in terms of the sensors, we used so far two kinds of sensors. One is like the Hukoyu LiDAR, which is used in Tacoma, and before that, Laserboy was built for the Lloyd's LiDAR sensors, which is I also used under the brand of Radar Touch.
So, then thanks again for this amazing insights, information and all. Great work. Now our last, but not least. Nice start. Sure.
All right.
You have the camera.
Wait. Yeah. I do have the camera. Oh, wow. I should share my screen as well, I guess. So it's gonna be a quick one. Just want to give you an update on our, what we are doing in the office in Berlin. Share the screen. So it's a very long and outstanding request, I guess. So I have any note, I don't know. Let's put a scene window here or something. That I can actually press Ctrl E, right, and have the inspector. The node inspector. So this is the demo, I guess. Yeah, as you can see that, I mean, some details here, I think, like you see in one go that some pins are, for example, I can, you know, like we have like on this node, some pins are visible by default and some are not, and the inspector immediately shows you those hidden pins, so to say, which you can enable, and you see to the left they pop up and disappear. So that should help a lot, I guess, because in the past you always had to go like configure and then look up this. It's let's try another node maybe. Let's try something like something simple. RDSR maybe, it's maybe simple enough to just show that here you can see that the RDSR, the node itself, is taking like here. You see it maybe in the screenshot. It's not taking a float or something, but an object here. And in the past, you usually had to go like RDSL settings and then create them here. I mean, just showing this in an example, there are other examples like this, where you had to connect it like this and then go to that node and modify everything. And of course, thanks to this inspector is also making use of the Imgoi object editor. Some people probably already know, which you can already use. It was already used in Kairos. Probably some other people already used it, I guess. And it gives you this nice option that you can basically just navigate into objects, and basically it opens them up. And that's why here we see immediately that I can just change the settings on the fly. And if I go, for example, for a skier node, like a text node, we should see in the inspector, I can also pin it. We should see here the output already. This is not yet final here. So basically what the system is doing when it has something, or I can also, maybe let's make it more clear on a texture, liquish or something. It's like a texture FX. If I click this one, I need to unhover, I need to go here. There we can see that what it's doing, it's showing you what the tooltip usually showed you in the past, no? So the idea here is that we could like make special outputs here, like a proper rendering, but if there's nothing else, it will always default back to the stuff what we already written for the tooltips. For example, that it will also work then, for example, out of the box for Fuse, where you see the shader rendering. Yeah, and everything else here, it's just Imgui. I can, of course, just change everything on the fly, and it's kind of what you expect. You see that the pins are, you know, changed. I can reset it. We see with this little icon right now, it's not final yet, that these pins are not basically assigned to any moment here. So it's basically just something you write, a constant which is given by the system. If you would connect something here, if I would connect an IO box here, then the pin, you see this icon here was removed, because it's basically the same what you see here, that it's now assigned an update. So this moment is called now on update, this pin, this fragment, while the other one is just there and it's fed by the default value. So these little details are all basically hidden here.
Is it a mechanism that we could have IO boxes that connect to the channel that you can write from outside to, and they will store the value instead of storing one?
What do you mean?
So you would have this IO box that's receiving the channel value, and then you could change it there with the IO box, but you could also write it from the outside.
But the scale, what I just did? No.
Yeah, this one, like IO boxes that receive channel value.
But this is not about.
I know, but is it reasonable that?
Huh?
Because now it's going away, but maybe it could be combining both worlds, and then it still have
I'm a little bit confused. Sorry.
Sorry,
Nah, I mean, let's put it that way. The inspector is, of course, meant to be that whatever I click here, it shows me those properties of this object I clicked. So, but I don't quite understand your question really, because if I connect an IO box and this is connected, then of course this pin is connected. I can't really change it, can I? Because it's already the value is already coming from somewhere.
Would write in the same channel, you know? That's the idea.
Yeah, but not sure I want this way.
I know.
Yeah, okay.
Sorry.
In any case, I think that's it. It's not merged yet back in the previews. It's still a branch I'm running privately here, but it will be soon. You see up there should be something like some help text maybe, or some stuff where you can go to the help page immediately, or these little things. But yeah, that's it. Thank you.
Amazing.
So then we jump immediately to the anonymous computer without any questions. There's one long question. Or are there any questions?
No, everyone's just.
Why is inspector spelled with a C and not the K?
Again, Suneb, we were too loud.
Why is inspector spelled with a C and not with a K like in the old in beta?
Yeah, why?
No idea. It's not merged back. Yeah, it's not merged exactly. It's still in a branch, you know. It's a prototype.
So it will be with K when we can get to it. It needs to be a K.
It used to be a K.
Absolutely, absolutely.
Very traditional people.
Yeah, Toby is asking if you can set attributes like min max.
That's of course the idea. So this is a step-by-step thing. So first this one goes out, and then once this is kind of okay, we can go to the next steps where you basically add the attributes and do all this. But yes, of course, this was the thinking from the start. So that, for example, I could click on a pin, like I have an input pin, and you click on it, and then you could say, yeah, what's the min, what's the max, and so on. Because the pin, if I click on a pin, it would show me a different thing. Because what we saw right now was a node. I've always clicked on a node. I never clicked on a pin. This is not done yet. But I think we can release one by one. I think this is already very helpful, and we don't need to wait for everything to be feature complete. Yeah.
Then should we turn directly here?
Do I stop sharing this?
No, you already shared there.
That's the stage.
Oh, sorry. I'm with some hard dreaming. Yeah, since the humidity in this room is so high, I will show you something very, very dry here. Wasn't attempt of it, you know. Anyway, so I like I know you like very dry stuff, no? So here's a patch called Errors and Warnings. And I will just show you, I don't know, a warning here. That's no camera. Okay, and sometimes your errors and warnings just hide somewhere in your patches, because you don't have only this little patch open, but you have hundreds of patches, and that's why now you have this little window that where you can just jump to whatever is wrong. There's an error, I can't see it because it's somewhere hidden in a different class, which is, you know, you only see it if you go here in this definitions window, then you see it, but in the main patch you don't see the error. Now with this extra window, you actually can see all your warnings and errors.
And yeah, that's basically it. There's your runtime warning, runtime error. And you can click this as well and jump to this thing. That's it.
What's going on? So many usability improvements. What happened?
Wake up, Chris. Wake up.
So, was no questions? Yeah, Toby K is applauding. Yeah. So let's have some questions. Then we hit the 3 hours and have the longest VVV meetup we ever did. I don't know if it's because of me, my premiere, or we had a so long break between the meetups. But we are already the longest. With 3 hours, we had a new benchmark. What are questions?
Is it already released? What? It's in a preview. We can download the latest preview and make the preview. So the inspector, not but the error. How to close this window, how to open. That's control. It's not decided yet. You'll find it.
It will find you. Yeah, like the control G, and suddenly there are global channels. And I was also thinking, what's going on? And after what is going on? Yeah. Well, it's amazing step channel, global channels for me was like, okay.
I have one question. If you introduce, first of all, really good that you have made these improvements, and you know I'm looking forward for the inspector for a long time. But if you introduce like these new multiple windows, it feels like there is only a small step for multiple patch windows.
Yes. I wanted to give you a demo, but it didn't start, it crashed. So just saying, okay. Yes, obviously that's the next, because you already feel it if you have the inspector open, another window open, it's just too much. It's not, it needs to talk in each other and whatnot.
Yeah, cool. Hooray!
Yeah.
So is this then happening on the next meetup? What will be?
Yeah, but if it's in January, for sure.
Maybe we should do one this year minimum. We can make it. I remember I was looking before training the last meetup, and Amir was saying we try to do it every month. I don't say this today because we didn't made it, but we will do another one. I think one minimum this year, maybe two. Perfect. We will see. We'll try. A lot of things happening. Also always an element, things popping up. Everyone join, share ideas, show new stuff. Stay in contact. Does anyone say something nice to everyone to go to bed?
Yes. Thanks, everyone.
Yeah. So then, let's say we quit this now and don't reach the 3 hours. We keep it for the next time. Yes. Bye.
Thanks, guys.
Ciao.
Bye, everyone.
Bye-bye.
Okay. Stop the recording. Yeah, but we didn't start with Punkt. Yeah.